So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own Mascota this side once again. The question for today is a very standard and very beautiful question. Construct binary tree from Inorder and Postorder. So let us have a look at the problem. Alright, so you have been given two traversals. One of them is in order, another one of them is post order. Now you have to create a binary tree using these two orders, using these two traversals. Usually this is the other way around, you get the binary tree and you have to give me the in order and post order, but it is always beneficial for the DSA skills to complicate the problem, right? Okay, so how is it solvable, right? What is the approach we are going to use? Okay, so to solve this problem you should have a clear understanding about the traversals. You should have a clear understanding about the traversals, right? So what is the technique of traversals, right? So in order, not to mention, in order is a traversal which follows the property: first it will traverse all the left, then it will traverse your root, then it will explore your right subtree, right? It will go towards the left as much as possible, then it will come to root, then it will come to right. And what about the post order? So post order says that first I will explore your left subtree. After that I will explore your right subtree, and at the end I will come to you. That is left, right, root. Left, right, root. You can check the given in order and post order are actually validated for this tree. They will come out to be the same. Alright. Now it is a given fact that if you have an in order and a post order, that then there is only one unique BT binary tree possible, right? So do not confuse that it might be possible to create another tree using that. It is not possible. It can be proved, but honestly I have seen the proof, but I don't know the proof, so I cannot prove it to you. But believe me, trust me, okay? In order and post order. Now how to use the in order traversal and post order traversal to do the same, to get the binary tree. Okay, so let me jot down the in order traversal and the post order traversal. Okay, you have the in order traversal as 4 8 2 5 1 6 3 7, and the post order traversal as 8 4 5 2 6 7 3 1. This is my in order, this is my post order, right? Now how will you proceed around it? How will you proceed around it? See, there is only one approach I could figure out for this problem, and if you understand the algorithm, that if you have been given in order and post order, how will you create, then the coding for this question is actually really simple, right? This is just playing with the index. Okay, so what will happen? Okay, so I know my in order is left, root, right, and I know my post order is left, right, root. Okay, I don't know about what is the depth of the left subtree and what is the structure of the left subtree. I don't know about the right subtree because of the same reasons. But I do know about root. A root element is only a node, right? Is only a node. See, the post order explores root at last. Post order explodes root at last. So does that mean that this element, the last element in the post order traversal, is my root? Does that mean the last element in my post order traversal is a root? Yes, as a matter of fact, yes, it is, and you can verify this from this figure also. Okay, I have got my root. Okay, so I will make my root 1, right? Now the in order says that I traverse root in between. I traverse root in between. Okay, you traverse root in between. Let me find the value where you are occurring with 1. Okay, this 1 is right here. I found the 1 in the in order traversal, and this one I got from the last element of the post order traversal. Now the root says on the left side I have my left subtree, on the right side I have my right subtree. That means on the right side of this 1 I actually have the right subtree of 1. I am saying on right side right subtree, and on the left side left subtree. Do anyone has any problem understanding that? I guess there is no problem. See, on the right side you have the right subtree, on the left side of the you have the left subtree because of the traversal of the in order that says me. This is my left subtree and this is my right subtree. That means 1 has the elements 6, 3, 7 on the right, and 4, 8, 2, 5 on the left. 6, 3, 7 on the right, 4, 8, 2, 5 on the right. That is 4 elements on the left and 3 elements on the right, 4 elements on the left and 3 elements on the right. And now what you can check is the 3 elements here and the 3 elements are here are actually same, not in the same order, but they are same. Why? Because it is right then left, that is roots right, that is this part and this part has to be same, and this part and this part has to be same, not in the order but the number of elements and the number of and the values of elements, they have to be same, they have to be same. All right, so I think that I'm clear here. So I'm saying 637 exists here, 4825 exists here, but I know I need to find the exact value, I need to find the exact node, and I want to continue doing that. I cannot say that roots left is this, root right is. Okay. So can I call the recursion here? Can I call the recursion here? See, most of the questions of the binary tree, I say 99% also are solved using recursion, right? Okay. So I got my 637 here. Okay, let me write it down. So in order said the order is 637. The post order says the order is 673. The property I use for one, that it is the root element because it is at last. Can I use it here? This is my in order, this is my post order. This says that 3 is actually my root at the right subtree level. That is, I will rub this down and I will say, instead of putting the whole vector there, I am just putting 3 here as my root. And where did I get this 3? I get this 3 from here, and this 3 is located here. That means this is my right again, 7, and this is my left, that is 6, which is validated by this also, right? So I actually got my right subtree full, that is 1, 3, 6 and 7. Same way I can do it for left subtree, that is it will be 4, 8, 2, 5 here and 8, 4, 2, 5 here, or 8, 4, 5, 2, sorry, 8, 4, 5, 2. That means I can rub this down and I can say my 2, this is 2 here, right? It is 2 here, right? So my 2 is my node here, 2 comes here, that is 5 is my right of 2. Okay, talking about 4 and 8. Okay, so 4 and 8 is my in order, 8 and 4 are my post order. So 4 is again the root, that means 4 here. Now as you can see, 8 is actually occurring on the right, that means it is right. So 8 is not on the left, it is on the right. Okay, and you can validate that this tree looks exactly the same as this tree. 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, and all the things are actually placed quite well, that is left are on the left, right are on the right. There is no discrepancy or tell, right? So what I'm doing is I'm taking out the last element from the post order. Let me write it down for the clear sake. Take out last element from post order, right? After that, locate that element in order. Again, no problem in doing that. So third, get your left and right elements. Okay, done for that. Get your left and right elements, no problem, and then make the tree. Now how will I use this to do the code? Let me write down the arrays again. So what do I say? I say I will use a recursive function. Let us say the recursive function says solve, right? And I will say that I will send my in order as usual, I will send my post order as usual. Now to define, like you can see here that we were using actually the numbers that were in the range of the left subtree. That first we wrote down that 4 8 2 5 are actually here, right? So 4 8 2 5 were actually marked from this index up till this index. Similarly 6 3 7 are marked from this index up till this index. So you get an idea, like in merge sort we actually use the play of index, we are actually using that only. So what I'm saying is I'm taking four indexes. First is for in start, that is where is my in order starting. In end, where is my in order ending. Similarly post start and post end, that is for post order traversal. Now when you are calling this solve function, from a driver code, you will obviously send 0 and minus 1, 0 here and minus 1 here, 0 here and minus 1 here. Why? Because you want to inculcate all the whole array in the tree, right? So what will this happen? 0 to n minus 1, 0 to n minus 1, that is from here to here, from here to here, right? What will I say? I will say that if my in start is less than in end, less than equals to per se, if there is only one value also, right? Less than equals to in start is less than equals to in end. In that case, what will I do? I will first take my node, that is my node star, let us call it as root, will become a new node, a new node. What will be the value of new node? That will be pos arrays, and this you can see this is my pos end. So I will say pos array, pos array, pos end. No problem. No problem, guys. Now, my second step was to find this element in this array in int. So what will I do? I will say for, like I will make index equals to -1 currently. Now I will say for int type. Now where will I search? I will search this in the range in start till in end, right? So for int type equals to in start going up till in end. That is the parameters for the in order traversal. I will say if that element is equals to this element, pos of pos end, pos of pos end. Congratulations, we have found our splitting point. What will I say? I will say assign that value to my index and break out of the loop, because I've got the value. Break out of the loop, right? So I will find my in end here. I will place my index here, right? It is 0, 1, 2, 3, 4, 5, 6, 7, right? Okay. So how many elements are on the right subtree? There are 3 elements on the right subtree. How many elements are on the left subtree? You can see 4, 8, 2, 5. 4 elements on the left subtree, right? I'll say the same. I'll say what are the elements on the left subtree. Now I have got my instart as 0, my index is 4. I want 4 in the left subtree. Can I say my left is equals to index minus instart? That is left is equals to index minus instart. Elements present in the left subtree of this root. Right. What are the elements present on the right? Elements present on the right are actually 1, 2, 3, right? And 7 minus 4 actually gives me that. So this is, as I said, this is just index manipulation. That is in end minus index. I got the elements, right? And I know these elements are equals to right and these elements are equals to left, right? So I just need to define the pos start and pos end for the left and the right. Okay, let me write. Can I say I will assign my roots left to B? I will call the solve function recursively. Sim, in and pos are same. I just need to define new boundaries for the in start, in end, pos start, pos end. So you can see for the left one, in start is actually remaining the same. So I will mention that in start is actually the same. Talking about in end, what is the in end? You can see my in end is actually index minus 1, nothing but index minus 1. So I can say in start will remain same and in end will now be converted to in end minus 1. Talking about post start, so you can see my post start was actually here, and for the left post start is actually here only. So I will say post start also remains same. So pos start. Talking about the pos end now. The pos end, how many elements? It is 0, 1, 2, 3. My left contains my 4. That is, I'm going up till pos start plus left minus 1. Pos start plus left minus 1. No problem in understanding, no problem. See, this is just simple index manipulation. The more you are better with arrays, the practice, you will be able to go through this question, right? Okay, so you got the left subtree correct. Talking about the right subtree, so you have already made this element as root. You have to get me the pos start here for this right subtree and pos end here, right? What will happen? This is my pos end currently, so as I described my roots left, I will describe my roots right, which is equal to solve. In and pos will remain same. Talking about in start now. So you can see my index was here, my right subtree starting at index plus 1. So in start will become index plus 1. Talking about in end. So in end remains same. Okay. So in end will remain same. Alright. Talking about post start is actually coming here. Well, this is my pos end. and I've got right, that is 3 elements. So if I say this is percent, this is percent minus 1, this is percent minus 2, this is percent minus 3. What is the value in my right? It is 3. So I actually want percent minus right. So percent minus right, that is my post start, that is my new post start for the right subtree. And what is the post end? That is post end. That is the same, right? Okay, so this will return me. After that, when both the subtrees have been done, I will say return root. And this loop, this if condition will end. If condition was in start should be less than equals to in end. Why did I put this condition? Because at some point in start will actually go across in end, and at that point I will have to return null. That means after this if statement I will say return null. Okay, and I will add this function. So what is actually happening? Actually happening is this one only, which I made through the subtree. Okay, so I hope there is no need for further explanation because I have pretty well explained, I think. But still, if there are any doubts, you know where to comment down, you know where to contact me, DM me, right? I have attached my social media handles below. So thank you for watching, and let us try to move to the code now. So alright guys, here is the coding section. But before starting to code, I would like to request you to please subscribe to my channel because it gives me a lot of motivation. Also please comment down and increase my like reach and motivation, right? Okay. So the driver function has nothing to do but just to call my solve function, that is return solve, that is my building function actually. So I will send my both the arrays, the starting point as 0 and minus 1, 0 and minus 1. This is for in and like parameters for in start and etc, right? Okay, now this is running me node star, function's name is solve, first array in order, second array post order, then I'm taking in start as my input argument, not to input, in end. Similarly I'm taking post start and post end. Now, my first condition was if in start is, I can say that if in start is actually greater than in end, that means I can say return null. And to better of this situation, I can say in start equals to in end. In that case, I don't need to do much of the thing. I will just say return new node. What is the value? The value is in of in start. You can actually do this using post start or post end also. The matter will remain same. Okay. Another thing. Now the case arises for in start is less than in end. In that case, we have to do processing. What was the first task? We said node star root equals to new node. What is the value of this new node? Pos of pos end, right? Now I will say I will try to find the value in the in order traversal. I will mark it as -1. I will say for int I equals to in start I less than equals to in end I plus plus. What do I say? If in of I equals to pos of pos end. In that case, my index becomes my I and I break out of the loop. Break, right? Alright, now I got the index. Now what is my left? So we discussed my left is actually equals to index minus in end. And similarly my right is actually in this is in start rise in start, right? In end minus in, right? Okay. Now we have just to define the right subtree and left subtree. So roots left subtree now becomes solve for both the arrays. The in start remains same and the in end now becomes, we discussed this thoroughly, let me open it for in the split window. So roots left becomes in start up till index -1 with post, let me zoom it out, post start with post start plus left -1. Let me zoom it out, right, for a clear vision, right? Now similarly roots right becomes solve for, this is not in, this is in here, in post, the arrays remain same. Now what is the starting point for in order here? Index +1, in end, pos end, in the post end it will be minus right, and percent as the ending of the post order, right? And then I will say return your root. Now I would like to submit this, right? Try to compile and run it. So in the meantime, I would request you to please subscribe to my channel if you have already not subscribed here. Oh, there has been some error. I have not declared it. Okay, it will be int in, right? Let us try to compile and run it now. So guys, you can also, oh, there has been some error. Post has not been declared. Oh, it will be post here. Let us try to compile and run it now. So there has been some segmentation fault, and I try to figure it out. It is post and -1. Why? Because we have already taken out the post and element, and it will be post and -1. Let us try to compile and run it now. I hope for the best it runs, right? So it is running fine. Let us try to submit it now. In the meantime, please do consider subscribing to my channel and tuning up with me, alright? So you can see 140 vendor streak long, right? So thank you for watching, thank you for supporting, and we'll meet tomorrow with a new video. Till then, you can watch another videos on my channel also. Thank you. Have a nice day.